morning.
The Space Center and are developing it as a technology.
My name is Maj Mirmirani, and I serve as the Dean of Engineering at Embry-Riddle Aeronautical University, Daytona Beach campus. My colleague Bob Bishop and I are fortunate to have a distinguished panel of experts who will be sharing their thoughts and views about the future of aerospace and defense industry in the United States. Together, they bring over 120 years of experience in this important sector of our economy.
We gave our share.
Aerospace and defense are the premier US industry, making a large portion of the US exports and extremely relevant to the engineering community and engineering education community in particular. The industry supports 1.7 million high-paying jobs. The income of A&D workers are 44% above the national average, $93,000 per year on the average. The industry represents approximately 2% of the nation's employment base and 13% of the nation's manufacturing employment base. It generates $300 billion in economic value, representing 1.8% of the GDP and 10% of manufacturing output. So we are very delighted to bring this panel to you. We are going to introduce our panelists, Bob and I, and then we turn it over. The format is that we introduce all three and then turn it over to our panelists. Let me start by introducing the gentleman immediate to my left, Mr. Norm Augustine. Of course, Norm Augustine really doesn't need an introduction. He is an aerospace industry giant, truly a national treasure. His countless accomplishments are simply too large and too long for this brief introduction to mention. So here is just an excerpt. Norm Augustine is the former chairman and CEO of Lockheed Martin and a former undersecretary of the US Army. He chaired commissions on the US space program for both President Bush 41 and President Obama, and chaired the congressional commission that prepared the Gathering Storm report on US competitiveness, education, and research. He is a former chairman of the National Academy of Engineering and former president of the American Institute of Aeronautics and Astronautics, and served on the faculty of Princeton University School of Engineering and Applied Sciences. He has been a trustee of Princeton, MIT, and Johns Hopkins, is a member of the National Academy of Sciences, and is a recipient of the National Medal of Technology. He has been presented honorary degrees by 34 universities. Bob?
And to the left of Norm, I'm privileged to introduce Frank DiBello. Frank is president and CEO of Space Florida. Space Florida is the principal state agency for aerospace-related economic development and the Space Authority for the state of Florida. In his position, he develops and executes programs designed to attract, retain, and grow aerospace business across the state. Additionally, Mr. DiBello focuses on Florida aerospace workforce development and retention, as well as international partnership development. He holds more than 50 years of direct aerospace, defense, and emerging space industry-related experience, including more than 20 years on new space businesses, taking major satellite programs to Wall Street for financing, and leading to the effort to develop commercial uses of the International Space Station. Mr. DiBello formed SpaceVest, a venture capital firm focused on investments in companies taking defense and space technologies to commercial applications and to market. He has served as President and CEO of Constellation Communications International, President and CEO of Florida's Aerospace Finance Corporation. Frank has been involved in multiple civic, social, and industry volunteer organizations. He founded the Washington Space Business Roundtable and was appointed to serve on a number of critical defense and space commissions and committees. For his work as president of the board of the USO Metropolitan Washington, he received the Medal for Distinguished Public Service, the Department of Defense's highest civilian honor. Mr. DiBello received his Bachelor of Science in Mathematics from Villanova and did graduate work at American and George Washington Universities. And Frank, when it's your time, I'm wondering if you could say a few things about Space Florida to let us have a better understanding of what that is. And to my right is Michael Cacheiro. Mr. Cacheiro has more than 28 years in the aerospace industry with a diverse background in program management, technical management, and business development. In his current role as Vice President of Commercial Space Operations for Lockheed Martin Space Systems Company, Mr. Cacheiro is responsible for leading the programs and operations for Lockheed Martin Commercial Space. This encompasses driving program operations and functional execution for commercial communication and remote sensing, as well as for execution and insertion of research and development for new technologies in support of commercial space on the A2100 platform. Michael's leadership path began in 1995 with Lockheed Martin Commercial Space as the A2100 spacecraft product manager. In that role, he maintained end-to-end product responsibility. Within commercial space, he is credited with delivering 11 satellites into operation. Mr. Cacheiro earned his bachelor's degree of science in aeronautical engineering from Embry-Riddle Aeronautical University in 1985 and his MBA from Rider College. He is active in the Hispanic community in support of STEM activities, including support to the MESA program at San Jose State University, and is currently the Space Systems Company executive on the Hispanic Leadership Council. So please join me in welcoming our distinguished panel. So our plan is we'll start with Mr. Augustine.
Okay, well, thank you very much. And as you know, our topic today is the future of aerospace in America as we see it, with a particular focus on commercial space activities. My views on the latter subject are fairly well unchanged, and from those already reported in the two commissions that were mentioned that I worked on for President Bush 41 and President Obama. As you may recall, both of those commissions came together and each unanimously recommended that it would be important to get NASA out of the near-Earth launch business. The view of the committees was, and it's my view today, that that flights to near-Earth orbit should be the role of commercial enterprises, and that NASA should focus its resources on longer-term, very high payoff pursuits such as space science, human exploration. There's an analogy here to the creation of the airlines. As you may recall, the federal government supported and provided a reliable source of capital to the early airlines in the form of contracts to carry the mail. And that provided the foundation of the airline industry as we know it today. And I think there's a similar role for the federal government in the space industry. The fundamental problems that were highlighted by those two commissions that I mentioned, and I think still pertain today, are that it's not technology per se that is our major challenge. Rather, it's the lack of funding that was available at the time we did our studies to support the space shuttle, to support science, and to support human exploration all at the same time. And the obvious answer, we thought, was to shut down the space shuttle program. That was a recommendation that wasn't greeted with great enthusiasm in all corners. And particularly when we added to that we should shut down the space station by 2020 or at the latest 2024. A lot of the problem is that we've been fighting the cost per pound on orbit metric, and it's been very resistant to major reductions in cost. And while certainly there's been progress made, there's been nothing even vaguely comparable to what we've seen in the microelectronics industry and several other industries. Certainly there are some foreseeable advances that will substantially decrease the cost to orbit, which is the foundation of the space program. But the likelihood of seeing the kind of revolution we saw in commercial aviation or in the commercial electronics industry, to me, is de minimis. Increasing travel volume is, to me, the only promising approach to quantum reductions in cost to orbit. And the only promising approach I can see to do that is space tourism. And by space tourism, I'm not referring to a few billionaires being launched vertically and taking a couple snapshots and then falling back to the Earth. Instead, I'm talking about relatively ordinary people going into orbit for a day or maybe two, taking photographs of the Earth, hearing lectures on astronomy, on space travel, and peering through telescopes at outer space, and experiencing weightlessness and even enjoying the pleasures of motion sickness. But the question, of course, is will people actually pay to do this? And it's my belief that they will indeed, and that they will do that in very large numbers, particularly when the costs become affordable and when safety begins to approach that was realized by the early airlines in our country. And you're all familiar with this cost-volume interrelationship where as you increase volume, cost tends to drop, which in turn increases volume, and you get what I call a self-eating watermelon. There are, of course, that would dismiss this notion of widespread space travel as a fantasy. I could point to many examples of why I believe it's not, one of which is that do you think that the Wright brothers at Kitty Hawk would have thought that it was reasonable that within a century nearly 10 million people would climb on a commercial airplane every day somewhere in the world and complain that they'd already seen the movie? We're likely to see, I think, just enormous change in the years ahead. But with that as an introduction, I'd like to observe that my two colleagues and friends to my left here are eminently qualified to talk about commercial space, particularly space launch. And so I'd like to talk about a little broader topic that underpins the future of aerospace, and I think the future of engineering in general. And frankly, I must confess that when I was asked to be on this panel, which I was thrilled to do because this particular audience is one that can make a huge difference in two areas that have been very important to me since my retirement exactly 20 years ago. What motivated me was to have the chance to talk a little bit about the subjects of research and education writ large. And in engineering today, one might say that these are the best of times and these are the worst of times. They're the best of times in the sense that there's huge opportunity. They may be the worst of times in the sense that there may be huge constraints on our ability to pursue those opportunities. Little background, about a quarter of a century ago, I asked 24 of my CEO colleagues that ran Fortune 100 companies that were highly involved in the technological world. I asked them to sign an op-ed that I drafted pointing to the importance of research conducted at our universities. And as we indicated in our paragraph or two that we'd written, that research by our universities was really the foundation of everything that we were able to build or do in industry. And that in turn, it was the foundation of job creation throughout the world. And as you know, there have been a number of studies, one of which was the basis of a Nobel Prize, that show that between 50 and 85% of the growth in GDP, read jobs, in the United States over the past half century are attributable to advancements in just two closely related fields, science and engineering. All but one of my CEO colleagues agreed to put their actual signature below the op-ed that I'd written, and we submitted it sequentially to the nation's major newspapers. And they unanimously arrived at the conclusion regarding our message that, in their words, research isn't of interest to our readers, and they wouldn't publish our article. We then reached into our corporate pockets, and we funded the publication of the article as a full-page advertorial in a number of newspapers. But you can imagine our consternation that the nation's media believes that university research isn't of interest to the readership. With this and several other closely related experiences that I had encountered, when I retired from my work in the aerospace industry, I decided that I would devote whatever runway I had left in life to promoting investments in research and education. And that posed, I might say, an interesting dilemma because, of course, I'm neither a researcher nor an educator, but strangely, that's proven to be an advantage. And when I speak about science and education, in spite of my principal roles in life as a business person and an engineer, as a public servant, I'm somehow granted a considerable credibility in the halls of Congress. On the other hand, when I speak about things like F-22s and F-35s, about which I know a fair about, I'm given very little credibility. And this incidentally has led to one of my newer laws that states that in Washington, the less you know about a topic, the more credible you are. In any event, the state of education and science that I observe in America is not a comforting one. And I don't refer to events strictly since the last election, but going back for several decades. Let me begin with education and the focus on engineering. Engineering education, of course, has its foundation studies in mathematics and science. And simply stated, our nation's K through 12 system is badly broken, particularly in these two fields, these two critical fields. Our students in K through 12 are rapidly descending to the bottom of the global class, at least in a relative sense. You're probably aware that international tests in math and science involving 15-year-olds from the OECD countries, that the ranking of U.S. students has dropped in the last 3 years from 17th to 21st in science and from 25th to 27th in math. And that's out of just 34 OECD countries. We truly are approaching the bottom. And not surprisingly, given that, today the fraction of baccalaureate degrees granted by U.S. universities that are granted in the field of engineering places us 79th in the world. The nation most closely matching us is Mozambique. Given this rather pessimistic assessment, it wouldn't be unreasonable probably to ask how has America managed to excel so much in recent decades in science and in engineering given these circumstances. And I think a large part of the answer is that we've been able to attract some of our very best students, a significant fraction of our university educators, and not to mention high-tech business leaders who've come from other countries to study at our universities, and some have managed to stay here. One of our nation's greatest competitive assets, in my view, today is our system of great research universities. It's a system that, as I'm sure you know, generally is ranked as All the top 5 universities in the world are in the United States, and by most measures, somewhere around 18 out of the top 25 are in the United States. But others are improving, and they're improving fast, and ironically, they're improving by, in many respects, copying things we've done in the past. And could you imagine a corporation that had a management training program telling its candidates for the program that before you could join it, you have to agree that when you've graduated from the program, you'll leave the company and join our competitor? Well, that's exactly what we do when we admit students to this country in many cases. Furthermore, you're all familiar with the disinvestment of our states and state universities. We've essentially are privatizing them, but without the sort of endowments that our great private universities have built, many over centuries. And this takes us from the subject of education to the subject of research, and particularly basic research, where I think all evidence is that we're severely underinvesting, and this impacts fields far beyond aerospace itself. A particular concern to me is the backlash that I think that may be lurking just around the corner due to the destruction of jobs by forthcoming advancements in science and technology. We've already seen the extreme reaction that's taken place to the loss of jobs from exporting work abroad. In the years ahead, I think it's very likely that far more jobs will be lost to technological advancement than will to exporting. Many new jobs will be created, but if you're one of, say, of the 4.5 million people who drive trucks in America today, and your truck no longer needs a driver, many of those individuals are going to find it very hard to adapt to the sort of jobs that are being created with new technology. And I'm not predicting that we'll become a nation of Luddites, but I am predicting that there may be a lot less support for research and technology than there is even today. So what are we to do? I have a large number of proposals. I'll mention 2 briefly. One is it's going to be more and more important for those of you in this group, this audience, to team, that's important, to team with business leaders in your state, to team with your governors, your politicians, with medical doctors, but go as a team and try to present the case for the importance of engineering. When you go alone, you're much less effective than when you can team up. The second proposal I want to mention, as I say that I could offer many, goes back to the fact that about 18% of our GDP today is devoted to the field of healthcare. It's been growing linearly and rapidly for the past 60 years. And if you extrapolate a little bit to the year 2032, just 15 years from now, we will be devoting 22% of the GDP to healthcare. The CBO has projected that in the year 2032, on the path we're now on, that federal revenues will be adequate to fund just 2 budget categories. One of those is to pay the federal debt, the interest on the federal debt, and the other will be to pay entitlements. There will be no money for education, no money for research, no money for defense, no money for infrastructure. So my question then is, why is it that we spend only 0.1% of the GDP on basic research in the biomedical fields, 0.2% of the GDP on basic research in all fields, including engineering, when we spend 18% of the GDP on the consequences of underinvestment in the causes of disease and related disabilities. And I should note that a recent study of practicing physicians indicated that 3 of the 5 most important advancements that they could cite in their ability to help their patients were pure engineering. So there's a great opportunity here, I think. And my proposal is simply that we double investment in basic research across the board, and that we could pay for that, given a little time, with reductions in the cost of health care. For example, if we could reduce cost of health care to that of the next highest developed nation in the world in terms of percent of GDP, 11%, the difference would pay for 2 defense budgets, 15 federal highway programs, and 1 K through 20 education program in this country. Others may question our nation's ability to afford an overall doubling in our investment in basic research. In my view, however, it's not a question of affordability, it's a question of priority. The good news is that basic research is so de minimis that my goal can be met, doubling funding of all basic research, because it represents only about 1/10 of what we spend on legal tobacco products, store-bought alcoholic beverages, and Halloween costumes for our dogs added together. Several years ago, I was testifying before a committee of the Congress, and one of the members apparently became tired of hearing my message and interrupted me and said, "Mr. Augustine, you're always over here asking for more money for research and for education." He said, "Don't you understand our country has a budget problem?" And I responded, probably more succinctly than wisely, by saying that I was trained as an aeronautical engineer, and that in my career I worked on a number of airplanes that were, during their development program, too heavy to fly. And never once did we solve the problem by taking off an engine. And I pointed out that science and technology and education are the engines that drive our entire economy and all these things that we can do. I, of course, don't know how much runway I have left to continue to tell this story, but I sure intend to keep pushing it because if we don't fix our pre-K through 12 system and invest adequately in research, there will be, frankly, no viable space program or many of the other things that we would like to do. I'm a living example, if you will, of the impact that these kinds of investments can make. I had the good fortune to attend a very high quality public school system. I was the first in my family to get to go to college. I had melanoma cured by the results of basic research, and I got my career to help play a tiny role in putting 12 of my friends on the moon. These topics really do make a difference, not only to individuals, but to society writ large. And so with that, let me thank you very much for inviting me today.
Frank?
Thank you. I always get a little embarrassed when someone comments in my introduction about how many years I've been around. But for all the years that I've been around, I've seen Norm Augustine as a luminary, and I think the country owes him a debt of gratitude for his vision and leadership during all of that time. I was asked to comment a little bit before I get into comments about the industry on Space Florida and what Space Florida is, because it is a little unusual. Space Florida was created by the legislature in Florida as a public corporation for the common good to serve as the state's spaceport authority, just like an airport or a seaport authority. But in that role, we have a statewide charter as opposed to one that is tied to a geographical area the way an airport or a seaport would be. We also have a dual role to serve as the state's agent for the development of the aerospace industry. And that means looking at the whole ecosystem in which aerospace industry thrives and attempt to provide policy guidance as well as some direct activity. We use the tools that we have as a spaceport authority to finance growth in aerospace. And I'll give you some examples just to explain the difference. In the spaceport role, we finance everything from launch pads to the vertical integration or horizontal integration facilities that enable spaceflight. In the aerospace role, we have financed research and development centers for a company like Embraer, It's the first design and engineering center they've placed outside of the country of Brazil, and we were able to build that in Florida. We're financing a significant campus for Northrop Grumman to do the design and engineering work for their next generation advanced strike bomber. And we can also finance tooling and equipment that goes into those facilities. And we have really focused ourselves on growing the space industry primarily, but these are horizontal industries that touch a little bit of electronics, a little bit of IT, a little bit of materials and structures. So we're interested in growing the entire spectrum. Following the retirement of the shuttle, which Dr. Augustine mentioned, we focused on ensuring that Florida would never again be maimed by an overdependence on a large federal program that got canceled. That's happened several times in our history. So the strategy for the state became to diversify the state's space industry and to build its supply chain. And that strategy has paid off, and that today Florida is no longer just launching stuff. We're actually building the rockets that we launch. We are building payloads, spacecraft, and satellites here in Florida. And I'll talk a little bit more about that. Now, the aerospace industry as a whole has gone through a period of both success and contraction over the last 30 years. The workforce in this country has come down from at one time it was 1.4, 1.5 million to just about half of that, although in the last couple of years it has grown slightly. The aerospace industry has been significant, and it's been last year as an example, one of the best years. It had 168 billion of exports to other countries, but contributed over 90 billion or close to 90 billion toward the positive balance of trade metric. But having said that, fiscal budgets, federal budgets around the globe have been tight and tightening. And when you add to that in the US the environment of sequestration, this has caused companies to significantly look at fewer new program starts and much more shelf life extension activity. So we're building platforms over long life, but looking at ways to refresh those over time. Coming out of Washington right now, it looks like there will be a significant increase in Defense Force buildup, which should create a modest budget increase of somewhere between 3% and 5%. And I do expect that under this Congress in the first year, we'll see the Budget Control Act of 2011 modified to eliminate or restrict sequestration provisions. And that should be a positive for the aerospace industry. The aerospace industry should see some growth in the defense area, but the driver for the past couple of years in the US aerospace industry growth has been commercial aviation, the significant portion of the growth that's been there. And we're seeing some leveling off, even downsizing in certain countries except China, which is a real driver. This environment has caused, especially the environment of fewer new program starts, has caused companies to look at consolidation. For the past 30 years or so, many aerospace companies looked at placing their operations in states, as many states as they could for political diversity in Washington. Now they are looking to consolidate, shorten their supply chain, and find a reduced cost of operation so that they can be competitive. At the same time that they are consolidating their operations, we're seeing that the pace of technology advancement in commercial companies is very, very rapid. And so we expect to see continued merger and acquisition activity in the industry as the larger primes reach down for new start technology companies that are advancing technology. This transitioning of defense technologies is also occurring as we become more digital, as we become more networked. I mentioned that we will see upgrade and replenishment of long duration platforms, but there's going to be an increased adaption, an increased emphasis on the adaption of commercially developed technologies to bring them in. And I expect to see space play an increasingly important role in next generation warfare as well as in our everyday lives from a commercial context. So where are these technologies going? First, I think that we will see this, whether these are satellites, small satellites or large satellites, platforms in high space, aircraft laden with sensors, or mobile platforms on the ground or in your back pocket. There are going to be increasingly networked and performing work for each other and sharing data. We'll see a big emphasis on hypersonics, and especially with all of these network platforms, emphasis on cybersecurity systems. And as these systems become increasingly heuristic, we're going to see them go from learning devices to heuristic platforms to full automation or robotics. I also expect to see breakthroughs in the use of laser and other forms of communication so that we can take all of the data being collected by all of those platforms laden with sensors, which creates a big data problem, and we'll see thousands of new companies spawned which can provide the high growth value added businesses helping us make good decisions with just enough data, not big data. The other thing that I think will happen as far as technology implication is that our factory floor will change dramatically. We're just beginning to see the impact of digitization in the factory floor and more integration of operations, but I think you'll see the fully integrated software in designed areas right through the shop floor, including the use of a lot of robotic and 3D printing and other kinds of advanced technology capabilities to take advantage of advanced sensors and materials, use of nanomaterials. The space industry itself has looked this way that you see on this chart for some time. Over 76% of the global space revenue is commercial today, not federal. And that's a significant statistic. Granted, a large part of that is the use of geostationary satellites to provide video traffic or feed our TV stations around the globe, but there are all kinds of other imaging and direct telephone and internet services that are provided by these satellites. But there are other burgeoning areas of commercial space activity that are attractive, and we expect to see that outlook continue. What's driving that is video and data and the incredible demand for bandwidth. Today, there are still 2 billion people in the globe that are not connected to the internet, and companies are scrambling to put global constellations of satellites, some as many as 800 to 1,000 and 2,500, and Elon Musk is talking about 4,000 satellites in orbit to provide global interconnectivity to allow a lot of those devices to feed the kind of big data solution that I was talking about. I mentioned we will see a whole host of new value-added services companies, and these are the kinds of companies that grow at compound average annual growth rates of 20 to 30%. So they're the ones we want to see enable and start up, and they'll be, I think, a factor for economic growth in the US and globally. All of this is going to have a major impact on launch demand, and we're already seeing a number of new entrants coming into the industry to try to drive down the cost of access to orbit. Some have a reasonable plan, but we're still fundamentally using controlled explosion as the means to get there. It's an adaptation of 11th century Chinese technology. And we are getting better at it. We're making smarter devices and finding new ways to build reproducibility into these systems. But what really is happening in this industry is that the private sector and the competition by a number of, and I count 13 billionaires, by the way, who have embraced space and are investing heavily in this industry. I'm showing 2 on the slide, but they are making significant advances in next generation platforms to drive the new space economy that is occurring. They're not only building rockets, but they're going to be building satellites, and they are changing the landscape, not just in Florida, but around the globe. Today, the Cape Canaveral Spaceport is the busiest spaceport in the world with 33 launches planned. Elon Musk plans to have 50 launches a year. That's 1 a week. When Jeff Bezos starts flying his New Glenn rocket, he plans to fly twice a week, carrying tourists up to the edge of space and bringing them back down again. That's 150 to 200 launches. So we're looking at a changed paradigm. And when you add ULA and a lot of these new entrants to it, we're going to be looking at launch activity around the globe that is going to significantly drive down the cost of launch, and with the factor of reusability of rockets, I think we'll see some breakthrough in launch costs. So what's the future? I think you're going to have to see a far greater leveraging by federal government of state and private sector capabilities, because federal government cannot move as quickly, and they shouldn't be financing infrastructure for the private sector. But the states and companies can, and the private sector, financial markets can do that, especially now that we're opening markets up. Rocket and spacecraft reusability is going to be a significant game changer for the industry as it drives down cost. And to comment on something that Norm said, and I know it's been part of his vision, I think the commercial industry is really poised to significantly expand its operations and activities, economic activities, in low Earth orbit. And I think not only some of the words coming out of the transition teams in Washington are that the private sector will play a role not just in low Earth orbit activity, fixing satellites, moving things around, delivering research payloads to the space station or other free flyers that may be up there, building facilities for tourists to get to eventually, but also going to and supporting the nations and global nations' exploitation and exploration of space. So while NASA may have the primary role, perhaps the logistics centers that support their staging areas will be commercial, and a lot of the exploitation activities. I think you're also going to see, unfortunately, an increased use of space in warfare, which is inevitable because space assets, that's the next high ground. But it will enable a lot of game-changing technologies that flow back to people of the Earth. So I do see the industry as a bright future, one that continues to contribute economic growth to Florida. And I'm going to close with the fact that space and the technologies that are advanced by it, whether it's keeping astronauts alive on long-duration space flight, or the kinds of discovery science that we make in plant and bioscience and bioagriculture in space, all of those things will flow back to Earth if we can harness them and invest in the research to apply them to our everyday problems, whether it's clean water or enhanced food production, or many of the, we're already seeing this happen in the biomedical area. So with that, we'll end and look forward to questions.
I was home on. Okay, good morning. It's a real honor to be here, and a real honor to be here with these two industry giants. I'm honored, and thank you for the opportunity, Maj. I'm going to take a slightly different tact here in that I am actually on a vacation day. I work for Lockheed Martin, and so I have to start with a little shameless advertising. So if we could hit the video, let's start with that. Try to inspire you a little bit this morning.
The future isn't written in stone. It can be guided and shaped, made better, more secure, safer. That's the power of innovation. At Lockheed Martin, we live on the cutting edge of physics, technology, and engineering. We're at the forefront of the science that turns impossibility into reality. We're working on the world's most advanced aircraft and combat ships, fusion reactors, and manned missions to Mars. And while we don't know what's going to change the world next, we're probably already working on it.
Well, once again, my name is Mike Cacheiro, and I am the Vice President of Commercial Space Operations out at Space Systems in Denver, Colorado. So it's a pleasure to be here. And what I thought I'd talk about in terms of the future of aerospace is that we're kind of the race is on. We've heard from both of our co-panelists here in terms of the changing dynamics in the industry. What started out 50 years ago as an industry that was fueled by sovereign nations is now somewhat of a global cooperation, collaboration. Instead of individual sprints to get systems into space, it's collaborations with partners around the world. We have launch assets that are provided by countries like Russia, the French. We have new entrants into the market, and truly our ability to continue to progress is based on this international collaboration. So I think I have to forward here. I don't think anybody who reads the news is not aware of the changing landscape of the industry. Frank mentioned the new entrants of the billionaires. We're very sensitive to that, of course, within corporate America. The landscape has now gone from what has traditionally been a federally funded small set of commercial entrants into space to now you have individual investors, private partnership corporations trying to get to space, the race to space. Elon Musk has been tremendously successful with SpaceX. What he first viewed as a non-entrant, now it's a real opportunity for continued space access for both commercial and military applications. You're also seeing a convergence of the industry. Just recently, Canadian company, MDA, who also owns Loral Space, it's one of the largest commercial space platform providers, is merging with DigiGlobe. DigiGlobe provides those beautiful images that you see on your Google Maps. And so companies are now trying to verticalize to provide end-to-end capability. And they go from being small players to major entrants that are true competitors within space. So the number of applications that we can take out of platforms that are in geosynchronous orbit, which is a continuous distance, 35,000 kilometers away from the Earth, that position themselves over a specific location, number of entrants in that field has greatly increased. We're also seeing a tremendous interest in low Earth orbit or elliptical 24-hour orbits where a large constellation of systems can provide advantages, ubiquitous coverage throughout the world through an integrated network, and you're seeing a lot of interest in that from an internet provider, data provider perspective. So the whole landscape is changing. It's very dynamic. There is an continued reliance on commercial as a means to fuel some of the innovation that's required, both from an affordability perspective and a technology perspective. You see my boss there on the lower left-hand side, Rick Ambrose, who's the Executive Vice President for Space Systems. He's made a pledge to continue to invest in commercial. Sometimes that's painful. It's not a guaranteed return, but it does help us. And our investment in commercial has really paid off as it permeates all sectors of space, whether it's military space, what we refer to as special programs, or civil space. Now, in terms of commercial space, I'll dive a little bit deeper here with you. This is our platform that's called A2100. It actually started with investment from Norm here back in the 1992 timeframe. He's painfully aware that he had to develop a next generation platform called A2100. Since that time frame, this platform has been launched roughly 50 times. So there's 50 different satellites orbiting the Earth at geosynchronous orbit. And once again, whether it's military space on programs like Advanced EHF or SBIRS, or civil space, like the GOES program, or programs like MUOS that provide narrowband communications for our warfighters in tightly confined urban areas, or commercial space. This platform has proven to be really robust and has lasted over a time. We're also using this platform in its next generation mode for the GPS program. And I think we're all aware of what GPS has done for us. Without GPS, you couldn't use your iPhone. You couldn't even use your banking systems. I think we'd be lost without the benefits of GPS, which is provided by the U.S. Air Force and is a free service to the entire world. So really incredible system. So with our modernized A2100, which you see here on the lower right-hand side, first satellite we're delivering are to the Saudis. Think about that. We're providing our next generation technology to the Saudis. 20 years ago, that would have been that wouldn't have been something we could have done. What you see are flexible solar arrays. That's a technology that really demonstrates how we innovate within industry. Sometimes people think of things in revolutionary terms. I like to look at technology as evolutionary. That same technology has flown on the space station for 20 years, and what we've done is modernize it, adapt it to today's solar cell technology, and we can provide payload capability anywhere from 7 kilowatts to up to 25 kilowatts in space. We also talked about, I think Frank mentioned the fact that we're using propulsion technology that China developed last century. One of the new emerging technologies within space is electric propulsion. It's kind of like the stuff you see on Star Trek, the ionization of electrons in xenon gas creates impulse. And electric propulsion today provides 10 times the delta V, or the ability to travel, than our traditional chemical propulsion systems. So it's an emerging technology, takes a lot of power. So if you have a flexible solar array and you have an electric engine, you can go great distances. So I think I'm running out of time here, so I'm going to move ahead a little bit. In terms of this audience, you are the premier educators within academia. I like to think that engineering is actually more difficult than medicine. What we're seeing more of in industry today is a growing reliance on high-tech simulations. You see on the left-hand side is how we use that simulation to actually duplicate an operation in assembly and test. That's actually the GPS-3 program, and we're showing the turnover of one of the system modules. That simulation allows us to significantly reduce risk when it comes time to handling high-value hardware. It allows us to anticipate the work instructions, the specific activities that need to be performed. It allows us to check out the tooling, the ground equipment, greatly reducing the risk for the program. Shown on the right-hand side, Frank mentioned 3D printing. It's a growing trend, and the industry isn't at the point where it can 3D print a car or an actual satellite, but we really are seeing an emergence of 3D printed hardware. Upper picture shows brackets, waveguide brackets that handle RF. We actually flew those on a mission that went to Jupiter, the Juno mission. On the middle picture, you see the Orion capsule. That was a famously successful mission where we took, it wasn't a man-rated capsule, but it was the predecessor to the mission that we're going to fly today, or in 2018. We flew that further than any mission in space since we've gone to the moon. We created some pressure vents on the actual capsule, and that went into deep space, came back, survived the re-entry environments, and that 3D printed capability is becoming a trend that's growing and growing, and it's a dependence on new materials, new digital manufacturing procedures is helping us advance in the industry. Well, speaking of innovation, I want to leave you with one video here, a second video that talks about where we're going. Norm talked about the importance of interplanetary exploration. The Orion mission was a really big, I think, shot in the arm for the space industry. Up until Orion, I think, since the cessation of the shuttle program, the enthusiasm for deep space travel somewhat subsided. It is back on, and it is fully supported by both Congress, Senate, the administration. There's a real excitement. A lot of students are excited about interplanetary travel. Let me show you a little bit about our plans to go to Mars. Oops. Okay, nearly 40 years ago, the Viking lander landed on Mars, and since that time there's been a fascination with the red planet, and it's ebbed and flowed, but there's been a constant interest in that environment. And since that mission, Lockheed has been involved with every mission that's gone back to Mars, and we're a true partner with NASA. We currently support the Orion program, which is the only man-rated version of any deep space mission. It's planned to be launched in 2018, and we plan to orbit Mars and then return the capsule back to Earth and successfully demonstrate that that can be performed. And then per the video, there's a plan to populate Mars with Mars Base Camp in 2030 timeframe, and it's amazing to think about that we're actually embarking on that. 30 years ago, when we talked about the race to space, it was predominantly who's going to get there first, the United States or Russia. Now there's a race between commercial sectors and commercial private sectors and NASA. So I think it's all good for innovation, drives innovation. So I'm going to leave off today with hopefully something that resonates with you in terms of what we need in terms of talent to support these industries, because we are seeing a shortage of engineers. We're seeing an over-reliance of bringing engineers in from other countries. From a talent skill basis, what we're looking for are engineers that specialize in material science, electric propulsion, digital technologies, big data analytics, digital design, digital processing, and specifically RF engineering, radio frequency engineering. That it really is, in terms of our demand for bandwidth. I think you all probably complain about the speed of your internet at home. That's only going to continue. Our ability to use up bandwidth will continue over the next 30 to 40 years, and space is the way to bring that down to the ground. So with that, I'll end here.
Thank you, Michael. Appreciate it.
Thank you.
Questions from the audience. We have 2-3 minutes, or maybe more, 7 minutes for questions.
Going
solar system. Could you comment on the vision for going outside of the solar system and any justifications other than science for doing that?
Well, wait.
I've heard every argument imaginable for why we as mankind should be reaching off. Manifest destiny, survival of the species, because it's there. But my reason, spin-offs, and as good as spin-offs are, they don't even begin to touch the logic of going out there because it's difficult and it's hard. And when we as a people invest in technologies to do hard things, we create a culture of innovation that flows back into every aspect of our lives. And we will have issues of survival of the species on this planet. Our population is growing, there are planetary difficulties. We might face some disaster from an orbiting body that does strike the Earth. There are all kinds of reasons why we should be looking to go abroad. But fundamentally, it goes back to bettering mankind by investing in research and technology and doing things that are difficult to create that culture of innovation that really does impact every aspect of our lives. Norm, I know you've thought about this
I
many
couldn't
times.
possibly do better than that.
Thank you.
Other questions?
Great talk. As an aerospace engineer, it's always great to hear this come up. Partnerships with private industry on in-earth advancements. We're still functioning over basic ethical MA to get stuff off the ground. Are there any moves to have advances in this area, especially in the propulsion area, propulsion and materials? I think that's sub-earth type of technology that we need to advance.
Sounds like yours.
Yeah, no, I'd be happy to. I think there's, unfortunately, industry tends to, when you're starved for funding, we pull pretty hard on our suppliers, and we negate the need to continue to invest in technology. And one of the things that I've seen work really well is when the labs, specifically the Air Force research labs, work with private industry to co-develop a capability, and that provides both a persistence and some resiliency from a funding perspective. So I think that's growing. You're seeing the emergence of small little entities, private entities that are working with firms like, or FFRDCs like JPL, AFRL, to develop specific technologies. And there's a lot of interest right now. Solar electric propulsion is a big buzzword. From what I see, a customer base, nearly every system that's being launched today has a path to get to electric propulsion.
Politicians of both Republican and Democrat flavors succeed in no small part by creating enemies, and then we defeat the enemy and all as well. In this most recent political cycle, my perception is that Trump and Republicans created an external enemy, Chinese, Mexicans, bad trade. The Democrats created an internal enemy, the wealthy. And it was just, the outcome of this election was really just a statistical anomaly as to which way it went. So I'm not wanting to get political at this. Either of them, I believe, could have picked technology as an enemy of the working man. So given that, I'm curious that your thoughts about how we avoid moving forward technology becoming that energy, and accepting what you said about the technology necessary to advance economic development. How do we make sure it doesn't become an enemy, and how do we make sure that that truck driver has a productive place in society?
It's a question that's not easily answered. I come back to sort of the fundamentals, and that is that we're going to have to change our education system, not only the quality of it, K through 12, but the whole structure. The idea that you get a degree in a field and work in that field, I think is gone. I think we've got to put far more emphasis on lifetime learning. We've got to put a lot more emphasis on apprenticeship programs for that truck driver. Unfortunately, I think there are a lot of people who will be trapped by changes in technology, whether it be the truck driver or the person at the grocery store counter, or you can go down the cab driver, you go down the list. But we're going to have to create a system where people can retool themselves throughout life. And I suspect you've seen the studies recently showing the shortening of lifespan for some middle-aged Americans, some groups of middle-aged Americans. And the explanation of that makes the most sense to me of those that I've read is that people lose their job, they lose their self-respect, they can't find a new job, and they become discouraged. I think it's going to be fundamental to anything we do to be able to find a way so that that truck driver does have an opportunity to learn something new. And again, I'm a big advocate of apprenticeship programs. I'm obviously a believer in college education, but I think there are a lot of people who a college education is not appropriate for, either because they don't want to go to college, or they're not interested in that, or they can't afford to, although hopefully we can solve that. But I think flexibility in our education system is going to be the byword. Do you want to pick up on that at all?
Well, the comment I would make is that I don't think technology is the enemy, but the inability to adapt to change is the enemy. And if we don't figure out how to move along with the rapid pace of change, and technology is changing things much more rapidly today than we've ever seen, that's what created a lot of anxiety for the millennials. It's not so much being separated from home as much as it is, there is a real anxiety about what they're going to do in life, and are they going to be able to find something to keep up with how fast they see things changing, and they work harder at adapting technology than many of us do. I'm still looking for the cursor. There are, in China and everywhere, societies are changing and they are adapting technologies, and I think whether you're a Republican or Democrat, we need to love our enemies and carry a big stick in our back pocket for national security purposes. But mutual well-being can eliminate a lot of that threat. If we figure out how to make it inadvisable for another country to go to war with us, whether it's from the array of weapons that we have or from the economic ties that we create and the other benefits that can be there, we'll see a lessening of tension globally. We have to put in place the ability to change, to adapt technology more quickly than we can today. That's true in our corporations, whether you're a large aerospace prime or even the small companies. I look at, I'm beginning to ramble a bit, but I look at a company like SpaceX, where the average age of the employee in SpaceX is 27. And he is adapting new technologies and also infusing current technology into his processes, which is allowing him to achieve some of the reusability and other breakthroughs that he's achieved. That means our corporate structures have to adapt. Those that don't have an average age of 27 are going to have to adapt either by embracing sub-tiers of younger companies that are bringing in these technologies. And I realize your question was about nations, but the same principles apply. China has as many problems of its own, and Russia has as many problems of its own that it's going to have to handle through the ability to embrace technology to alleviate a lot of its problems.
We are at the time. We allow one more question if there is. Okay. Well, let's give a big round of applause to our